The notes for Unit 5, Lesson 6 will cover stoichiometry. Stoichiometry examples would be in Chapter 12 of your textbook, and this is the process for calculating unknown values in any given lab scenario. So, for example, we use the example of a recipe. If you are making cookies and you have your flour and butter and sugar, stoichiometry can help you figure out if you use 2 cups of flour, how much butter would you need? Or if you use 6 tablespoons of butter, how much sugar would you need? So it's kind of like converting and figuring out how much of each ingredient you would need or how much of each product you would end up with. So this might be you over the next few days, every day. What is this? What is this? So don't feel bad if you're confused. This is a very difficult concept. But keep in mind the process that we use for stoichiometry is the same as the process that we've been using for mole conversions. So it is new, but it's not entirely new. All right, so in your notes, we have a few sample problems. So the mole map, which looks like this, is on the back of your yellow periodic table packet. It's on the very back page. So the mole map is super helpful because it gives you directions on what to do. So you find your starting point and your ending point, and then you follow the path on the mole map that it takes you to get there. So I'll show you how to use that with this example. So in this first example, we want to calculate the mass of H2. So mass, remember, is in grams. So we're going to start here. We're starting with the mass of H2, that's what we want to end with, and we're given 25 grams of N2. So because N2 and H2 are different substances, that's when you cross over from side A to side B of the mole map. So side A, for example, would be nitrogen, which is what we start with. Side B would be hydrogen, which is what we are going to end with. So when you switch substances, that's when you switch from side A to side B of the mole map. All right, so we're going to start with the number given in the problem. So when we set up our problem, we're going to have question mark grams of H2. That's what we want to figure out. And we are starting with 25 grams of N2. So again, on your mole map, we'll get our problem set up here. So on your mole map, you're starting with grams of one thing, and you're ending with grams of another. So to get from grams of A to grams of B, first you have to convert grams to moles, then you have to convert moles of nitrogen to moles of hydrogen using your mole ratio, and then you're going to convert from moles to grams. So this tells you the steps that you need to finish this process. All right, so if we go back down to the problem, the first step is going to be converting grams to moles. We know that whatever unit you start with on the top gets transferred to the bottom of the next step. This is grams of N2. So when you're going from grams to moles, we are using the conversion factor that the molar mass is equal to 1 mole. So molar mass is in grams. That comes from the periodic table. So if you look at the mass of nitrogen from the periodic table, it is 14.01, and you have N2, so you have to take that value times 2. So the molar mass would be 28.02 grams of nitrogen. From our conversion factor up here on the mole map, we know that the molar mass is equal to 1 mole. So that mass is equal to 1 mole of N2. So that would be your first step, converting from grams to moles. Grams cancels out, and we're left with moles. So now on our mole map, we are here at moles of A. Now we're going to go from moles of A to moles of B. So that's when you're going to use your mole ratio. Your mole ratio comes from the coefficients from your balanced equation. Oops. So when you compare your mole ratio, remember, same process, whatever unit you start with on the top gets transferred to the bottom of the next step. So for your mole ratio, this is when you look at your balanced equation. So we're comparing moles of N2, which is what the problem started us with, and we want to end with moles of H2. So for this problem, we're only comparing moles of N2 to moles of H2. Moles of N2 goes on the bottom of the chart. If there's no coefficient, it's assumed that it's 1. And moles of H2 would go on top, and we have 3 moles of H2. So that is your mole ratio from the balanced equation. Moles of N2 cancels out. Now on our mole map, we have gotten over here to moles of B. So now we only have one more step to do. We have to go convert again from moles to grams, but in this case, we're converting from moles to grams of hydrogen. So whatever unit you start with on the top gets transferred to the bottom of the next step. Now we're using this conversion factor. So 1 mole is equal to the molar mass, which would be grams of H2. Grams of H2 comes from the periodic table. So hydrogen has a mass of 1.01 and we have H2, so we have to multiply it by 2. So 2.02 grams. Moles of H2 cancels out. So now we are left with grams of H2, which is what the question is asking for. So once you have this unit, grams of H2, on the top of the chart, then you know you're done. We also can go back to look at our mole map. Here's step 1, here's step 2, here's step 3. Here's step 1, here's step 2, here's step 3. So you can kind of double check that way as well. So once you're done, you multiply all the numbers across the top, divide by all the numbers along the bottom. So 25 times 3 times 2.02 divided by 28.02. And now we have to round to sig figs. So when you look at sig figs, we'll look at all the numbers in the problem. 25.0 has 3 sig figs. The molar mass has 4 sig figs. The mole ratio, you do not use 4 sig figs. So you do not consider your mole ratio for sig figs. And then this last number, 2.02, has 3 sig figs. So our answer will be in 3 sig figs. So we would round our answer to 5.41. And then it would be grams of H2. So what this problem tells us is if we started with 25.0 grams of N2, we would need 5.41 grams of H2 for this reaction to completely occur. So this would be a grams to grams calculation. You're going all the way across the mole map from mass of A to mass of B. All right, the second problem, we want to calculate the volume of NH3. So remember, volume is in liters. So we would end at volume, and we would start with grams of N2. So we're starting with a mass, and we're ending with a volume. So we're going to go from grams to moles, and then since we have 2 different substances, we're comparing NH3 to N2, and since they're different, we have to look at the mole ratio, and then we're going to go from moles to liters. So we would have our question mark, to start off the problem, we would have question mark liters of NH3. Oops, my pen isn't working very well. There we go. And we would always start with the number given in the problem. So when you do these long problems, you always have to label everything. So for example, instead of just saying 54.5 grams, we should show that we have 54.5 grams of N2 because now we're comparing 2 different substances. All right, so we know that whatever unit I started the problem with is going to get transferred to the bottom of the next step. So grams of N2 goes in the bottom. This is my first step. I'm converting grams to moles. To do that, we have to use the molar mass, which comes from the periodic table. So nitrogen has a mass of 14.01. Nitrogen in this example is N2, so we have to take 14.01 times 2. So we find that we have 28.02 grams, and the molar mass is always out of 1 mole. So that would be in 1 mole of, H2. Or N2, sorry. That would be in 1 mole of N2. Grams of N2 cancels out. Now we are in moles of N2. Now we're going to compare the mole ratio to convert between N2 and NH3. Again, whatever unit you have on top of the chart gets transferred to the bottom of the next step. So this is my mole ratio, and my mole ratio comes from the balanced equation. So I'm comparing moles of N2 to moles of NH3. So now I'm only looking at the ratio between N2 and NH3. So moles of N2 is on the bottom of my chart. If there's no coefficient, it's assumed that it's 1. We're comparing this to moles of NH3, which from our balanced equation tells us that we have 2 moles of NH3. So moles of N2 cancels out. Now we're in moles of NH3, so now we have to get from moles to liters. So we will use this conversion factor. We know that 1 mole of any gas at STP takes up 22.4 liters of space. So whatever unit we have on top of the chart gets transferred to the bottom of the next step. From our conversion factor, we are only looking at 1 mole, so we know 1 mole of gas takes up 22.4 liters of space. So since we're going to liters, we need liters on top. We do not have to calculate the molar mass of NH3 because we're not ending with grams. So that's where your mole map really comes into play, is it tells you where to go so you don't accidentally calculate the wrong value. So moles of NH3 cancels out, and now we just solve. So we multiply all the numbers across the top. 54.5 times 2 times 22.4 divided by 28.02. And then we have to round to sig figs. So the first number, 54.5, has 3 sig figs. Our molar mass has 4 sig figs. The mole ratio we do not use for sig figs. And then 22.4 has 3 sig figs. So our final answer would be 87.1 liters of NH3. So this is saying if we started with 54.5 grams of nitrogen, we would produce 87.1 liters of NH3. So when you're doing these problems, always look to see what information is given in the problem and what information you want to end up with. And then you find those places on the mole map. So for example, if you start with grams of one thing and want to know atoms of another, you find your starting and ending point and you follow the path that it takes to get there. If you had a calculation that gave you volume to start with and asked you to solve for grams, then you would start with volume and follow the path that it takes to get from volume of one substance to moles of another. So the mole map can help navigate. One last thing to remember is you would use this mole ratio from your balanced equation when you're converting between 2 different substances. So because we started with N2 and wanted to end with NH3, those are different substances. That's why we had to use the mole ratio. If we started with N2 and ended with N2, then we would not need to use the mole ratio. So those are things to keep in mind. One other reminder is in order to compare two substances, you have to compare in moles. Moles is the only way to compare. So if you have no idea what to do in the problem, at least convert to moles, because then once you get into moles, then you can use that ratio from your balanced equation to figure out how those two substances are related. So hopefully this helps. As always, let me know what questions you have.